What's it mean to be a function?
Yeah.
You could graph it, but what is it? That is a function. That's a type of function. What determines functionality? Y'all clearly don't remember this. I should just tell you. I should just tell you. Okay.
One and only one output.
That's what I said. I'm sorry, Miguel, I didn't hear you. Output being Y, input being X. A simple way to check, y'all keep talking about a graph. A simple way to check is, does it pass the vertical line test? Do y'all remember vertical line test? Okay. Let me show you what that means, because if you didn't have me, maybe you didn't ever see it. Okay. Not doing what?
Pencil test? I hate it.
Tell me what you think the pencil test is.
No, like you do like. There's exactly. I don't know what it is. And I always get.
But you hate it. You can't hate it if you don't know what it is.
Yeah, but it's just like because it made me get bad grades. Like. It's like
That's what it was. That's what it was.
There
was the pencil test. That was the whole. All right. The first one is a function. There's nowhere on here on that first one that I could drop a pencil and it would hit more than one time. So it passes. This one, however, look, if this was my pencil. This is a pencil. So this one's not, right, because my pencil would hit once and twice. You can only hit once, you can never hit more than once, and then it fails. Okay, we call it not the pencil test, but the vertical. Look at there, the vertical line test. There's your. Right. Right. The second one's not a function. The first one is a function. Okay. Okay. What if I gave you some points? Is that a function, yes or no, and why?
Yeah. No.
Why?
Y can be the same. The X can.
No, the X can be the same.
The Y can't be the same, right? Because it's got to have, if the Y is the same whenever you graph it, right? If I come here and I go to 1, and I have 2 different Y values for the same, so, ooh. Yeah, y'all were backwards. See, I know I'm getting myself mixed up. I have to grab it and look at it. So let's think about what this point would look like. This point would be like 1, 2. This point would be like 1, -1. So you can't have repeating X. No repeats on X, but you can repeat Y, because that's just going to put it over, and I'm still sitting here going, what? Okay, this point could be -1, 2, and you see here, if it, I know, but I'm showing you an example. If this point was not in here, then it would be a function, right? Even though these have the same Y values, it could still be a function. It passes the vertical line test. But if this point was not what I was looking at, these two could not be a function because it does not pass the vertical line. You see what I'm saying? So No, that you can't have the same x more than one time. Because then that x would have various outputs. And every input can have one and only one output. Is that okay? Are y'all good with that? Y'all understand? Look at this one. Number 3. Yes or no?
Yeah. Yeah.
All right, let's see. So some of the y's repeat, right? Because this 0 has two different x values, but that's okay. I just can't have the same x value going to two different y's. Does that make sense? Do you see how it's mapping there? How about number 2 on that one? Is that yes or no? Yeah, we're fixing to talk about that again. I told you we're just going to cut. I always say look left to right on your graph. And then range describes y's, that's bottoms up. The lowest point up to the, why? It's catchy, Dozier. No? Is it bad?
No, it's just lifting on the screen.
He got it from me. Yeah, it is.
It's Nicki Minaj.
All right. From the lowest point up to the highest point, okay? And then sometimes we have to leave stuff out. All right. Let's look at a graph. And let's see if you can tell me domain and range and some. That's kind of a review. Let's say that's the 3. Okay, my first question is it a function? That's a function. Yes, that's a function.
It crosses the Y.
Okay.
I know
It is a function. It is a function. It is a function. It passes the. Where can you put your pencil and it hit more than once? So it is a function. Okay. We got you, Noah. We're going to help you through this. All right. Domain. So left to right. What's the furthest left it goes? Negative infinity. So my domain is going to start. I'm going to do a parenthesis because I can never remember. Parentheses don't include. Brackets include. I can never be infinity. That's a conceptual term. So I'm going to go negative infinity. That's a terrible infinity. And then I do a comma and I go up to, well, how far right do I go? As I start trucking right to positive infinity. There's nothing that ever stops. All real numbers. That's exactly right. That's the same thing. Let's look at the graph left to right. What's the furthest left it'll go? And because these legs here are kind of inching out as you go, then it goes out and down forever on both ends. The dots. Okay, how about the range? What is the lowest the graph ever goes? Let's start at that. Negative infinity, right? And now as I make my way up, I go up, 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 up. Where do I stop? Right here, right? Well, okay, pretend like it does. Y'all knew what I was getting at there, right? So that is what, remember range is y, so what's the highest y value this graph goes? 3. Do I need a bracket or a parenthesis? Why? Definitive? Yes. It includes it. Because there's actually a point there. The only time it's not going to be is if you have an asymptote or you have a hole in your graph. We'll talk about all types of discontinuities like holes and things like that, but not yet. But if it does not include it, then it'd be a parenthesis. But most of the time here so far, at least the ones that you know. Bonus round. What type of polynomial is this? A double. Nobody? Oh, come on, y'all.
Are we doing? Give me a hint. What is it start with?
That'll give it away. That'll give it away. A Q. Q.
No, wait.
It's not quadratic.
Quadrant.
You're close.
It is quadrant, look.
Quintic is a fifth. It's not a fifth.
Oh,
No, wait.
No, don't give it away. It's a quartic. It's a quartic. I didn't hear you, Miguel. I'm sorry. I thought I said quintic. You said quintic. Okay.
Yes, go grab one. Yes, go grab one.
Because it's going down forever.
Yes.
So the lowest it ever goes, it goes down forever. So that's negative infinity if it goes down forever. And then I keep going up until I hit here and it stops. Y'all okay?
Yeah, except that Taylor doesn't want to be standard.
No, I don't want to be standard.
Yeah. All right. Just as a review in algebra.
They're not wasting the sandwiches.
Well,
We play great because these why?
aw.
That's funny.
Okay.
That's funny.
Polynomials start linear. Remember, we class them by the degree. The degree is the biggest exponent, and we start with linear. And then if I add a degree on, what am I at?
Quadratic.
Linear, which would be just like y equals x, right? And then I go to quadratic. That's the squared. It's like x squared. If I add another onto the degree, what am I at? A cubic. Y'all didn't learn this? No, I know you did, Miguel. I taught you. Yes, you remember. Yeah. If I add another degree, Quartic, don't listen to him. And then up another would be a quintic. That's right. And that's as far as we name them. Yeah.
Now, then there's another name you give it. It's
Nth degree polynomial. Nth degree polynomial. So if past 5, we'll use, like if it's a 10, we'd say 10th degree polynomial. What do you mean, how do I know this?
So what? So
How do I know that this one's a quartic? I looked at the number of humps on it. Remember, because the way these look, all right, so linear looks like that, right? Quadrat, whoa. Only 3 what? All right, but watch what happens. So that's a parabola, that's a quadratic, right? Cubic does this. Quartic. But it could go either way. It could, yeah, right. It has to do with your humps in it. But as you start, that's not a really good, it's a good way to look at this and know what it is, but sometimes we'll get, these will be so stretched out, they're not pronounced humps anymore, but anyway. I digress because none of that was intended to show you today. I just, whenever I say stuff and y'all look at me like you've never heard it, it just,
We want to.
yeah. Look at that.
We make it.
I know. No, I don't.
No, we tried a bad teacher.
I don't think y'all are dumb at all.
Miss McGee, when we turned in our test grades at the end of last year, I remember you were like, these are the worst test grades to ever come through here. And I had to pass like Cause I made like the diagonal.
Function, yay or nay?
Yeah.
Well, yeah.
Yes.
Yes. Yes. That's not logarithm actually, because it has an endpoint like that. It's very similar, but a logarithmic, remember those log graphs, they have a vertical asymptote on them. Any guesses on what this is?
Linear.
It's a square root. That's exactly right. It's a square root graph. This is a square root graph.
I remember because I had used linear.
Yeah. Did y'all at least do a project like I had mine? Because I sent her all my stuff. The linear, I mean the. Which one? That's Hannah.
Or like, some are taking forever.
Yeah,
We work on projects in class. If I ever do a project,
She wouldn't let us.
Miss
She
McGee
took
gave me
points
a
on me,
25 on
extra credit video because
mine.
she put load on her end.
she was 90.
She was a 92, it brought our grade down because it was extra credit.
I drew 3 trees and I got a 25.
For which project? That project?
One of those.
No, I don't want you to do
I
it.
literally
See,
got
that's what you get. This is why I don't give homework ahead of time. Okay.
You said do it like that. What is that?
Okay, square root graph, yes. We're going to spend some time here, maybe tomorrow, maybe the next day, where we're going to talk about all the parent graphs. And so we'll review all those parent graphs like this from Algebra 2, so don't stress if you don't remember them. All of the quadratics and cubics and square root graphs, all those good things that we're going to be transforming and stuff, and then we're going to add some to that. But for this one, what's the domain? -2 to infinity. Do I need a bracket or a parenthesis? And then the range, there you go, -3 up to infinity. Yeah.
So what kind is that again?
This is interval notation. Are you talking about the graph itself? It's a square root graph.
That's a quadratic.
It's square root.
That's what I had to do.
Okay, you're thinking about growth or decay. And that's not what this one is.
A freshman, I'm like, there's no way I'm supposed to be in this class. Like, I'm not that smart, but I had the highest
For what?
GPA by like. Oh,
Oh,
good
for domain. Yeah. Yeah. No, there's an asymptote there.
I don't know how I got put in that.
No, this week, I'm pretty sure that's 100 to 100.
I had to learn the Beckley class and all that.
This is actually the reciprocal function. We'll talk about it. You haven't learned this one yet.
Wait, yeah, no, I do.
You do? What's the domain? They both make up one graph. So looking at it as a whole, what's the domain? Close. Let me give you a hint.
That's split this, so that means that it's. They don't attack.
You have to do a U. That's exactly right. So my domain, while it goes from negative infinity, it goes up to what before it breaks? 2, and it goes 2 up, break. Can it be 2? No, that's an asymptote there, right? So I do a parenthesis, and you're right. This is where I hit it with a U to say I need another piece to go with this. And I pick back up at 2, and then it goes on until what? Infinity.
You bunch of mathematicians don't like being wrong, so it makes up.
Wait, so the sum of that.
That's the domain. So left to right.
Oh, we just go to the point where they're like.
Right. That's exactly right. Now, how about range? Same process, but this time instead of left to right, I'm going bottoms up. So the lowest it goes is what? Negative infinity. And then I start trucking it up, and I hit a roadblock when I get to 0, right? This should be on 0. And this is actually hugging. I just did a poor job drawing. Because it can't actually be 2. You see how this, you know, you've heard about asymptotes. You've learned asymptotes before? Did you? Okay, so an asymptote is an invisible boundary. And the graph always hugs it, whichever way it comes in and hugs it. It hugs it, it gets so close, but it never touches it. So think about, right, so like here, think about getting closer to 0, like if you keep cutting something in half. Take a half of 4, and you get what? 2. Now take half of that. Now take half of that. Now take half of that. Okay, so now I'm in a 4th, take a half of that. An 8, take a half of that. Could you keep going on forever? Will you ever be 0? Here's the asymptote there. Does that make sense? So I can't actually be it, so I put a parenthesis there. But I can get really close, but I can't actually be it. Same thing here. So I get really close to 0, but it can't actually be 0. And then I pick up on the other side, and I keep going forever. Alrighty. You don't have to know the names of them. You don't have to know the names of them. We're going to go over all that.
That's a reciprocal function. I hate them so much.
I'm fixing to show. What's that mean? F of x, which tells me that it's a function. It's function notation. Ooh, I'm thinking name and rote notation. It's function notation, and it gives my function a name. That's all it does. It gives it a name, and it tells me what the variable is in the function. Okay, and whatever I put in those parentheses is what goes in place of the variable. It doesn't matter what it is. If I told you that f of x is 2x plus 3, and I said, what is f of, I don't know, f of apple? The point that I'm getting to is it doesn't matter what's in parentheses. This would be 2 times apple plus 3, right? Whatever it is what's going in there. Y'all okay with that? Most of the time it's a value, and I'm putting the value in there, but we get to times when we put whole other functions inside functions. Remember f of g of x, and we take that entire function and we plug it in there. Okay. You're good at that? Good. I think one more thing, and I should be good. Writing equations explicitly. You should know how to do this. You just may not have been told about it in this form. So if I gave you an equation, let's say, let me get it. I have a whole set of classwork stuff and then a set of homework stuff. So I'll pull examples from the classwork stuff so I don't use up all your nice examples from the homework. If I asked you to write this explicitly in terms of x, in terms of x means I want only the variable x I want it solved so that the equation only involves the variable x and doesn't involve any other variable. So in other words, there's 2 variables in here. I want this to say y equals whatever, and x can only be on this side. I can't have x over here with y anymore. It's got to be in terms of x. So I've got to solve this for y, but I in a bit of a problem. So here's let's walk through what we're going to do. The first thing to always do is we're going to get all the y's on one side by themselves and all the x's on the other side by themselves. Okay. So here, and I'm sorry this is such a patchy lesson. Like we're going from this, because this is just kind of a background review stuff for what you need to do the rest of this unit. It won't be like this through the whole. I see though that I've got one that's got both x and y in there. So it's going to be hard to go right on its own. So now what I have to do is I have to think, well, what in the world am I going to do? My goal though is to get y by itself essentially. Solve it for y. Any ideas? Look at you, Miguel. Did you hear what he said?
Move the y to the other side, factor out the y.
I think you meant 1. Move the 1 to the other side. So now I have xy minus 5y equals 2x plus 1. And now I can factor a y out. Remember, my goal is to solve it for y, right? I've only got y on one side, but to do that, I only need one y. I've got 2 y's right now. But if I took a y out here, now I have now I have y written only one time. Now I can solve it. What do you do? Yes. Divide by x minus 5. Okay. That would be the answer. This looks like a rational function, which we'll get the graph real soon. Aren't you excited?
Yeah. How do you
Yes. What is? I think that's in terms of x now. Because in terms of x means I've got y equals, and there's no other y's on this side. There are only x's over there. They just always say in terms of. Think about it in terms of if you did f of x, that's in terms of x, whatever that variable there is. Yes, yeah, that's an easy way to remember it. All right,